Okay, so this video, I'm going to explain the definition of adiabatic condition. So what is an adiabatic condition? So if you Google that, you'll get a definition like this. So an adiabatic condition or process is defined as the thermodynamic process in which there's no exchange of heat from the system to its surrounding environment. Okay, so what does that mean? If I open up DesignBuilder, I'm going to start a new file. And right now the climate is Boston. So I'm going to take that. All right, so if we, let's see if I sketch on this, let's say if we model a building in DesignBuilder, and by default, the program will know that this floor is touching the ground, and that's by default. So this floor is touching the earth, and then this wall here is touching the outside condition. Okay, so you have the outdoor element, and this roof again is touching the outside condition. So that's all by default. But sometimes you might be modeling a portion of a building. For example, you might be modeling this entire building. Okay, this is the entire building here. But you only model the red part of this building, okay? So this wall right here is essentially not touching the outdoor elements, is actually touching the rest of the building. So this wall right here, you don't get heat gain or heat loss because you're assuming that this next door room is having the same condition as this. So there's no heat transfer between these two, because you're assuming that the entire building is operating under the same climate conditions. So this wall right here is the adjacent wall between this space and that space within one building. And we call this wall adiabatic wall or adiabatic condition, as opposed to this wall, which is not, because this is touching the outdoor condition. Okay. So another example is that, let's say you're modeling you're studying a 3-floor building. Okay, you have 3 floors. Sometimes in order to make things easier, if we only trying to study the top floor of this, okay, and that's what we're interested in. So we don't have to model the entire building. We could just model the the top floor of this building, okay, and just model it without modeling the lower 2 floors. But now this floor down here is not touching the ground, is touching the adjacent floor below that. Okay, and the floor below that is having the same climate condition as the indoor environment on the top floor. So this floor here is essentially an adiabatic condition. Okay, it just means that the other side of the surface is having exactly the same temperature condition as the space that you're interested in. So there's no heat transfer between the two sides. Okay. So I'm going to use this as an example and just to kind of show how to study a particular floor, assuming that one of the surfaces is an adiabatic condition. In this example, will be the floor of the space. Okay. So I'm going to pretend to add a building, and again, I'm trying to simulate the top floor of a building. So I'm just going to model one floor. Okay. So let's say my building is about 140 feet by 43 feet. Okay. Okay, now if you don't do anything, then the program is going to assume that the bottom of this 1-story space is the ground floor is touching the ground, is touching the earth. But if this indeed is the top floor of a building, the purple floor is not touching the ground, is the roof or the ceiling of the next floor down. So this purple space, this purple surface will be an adiabatic condition. So how do you define that? it's very simple. You just go to the zone and select the ground floor. Okay, that's the ground floor. And we just define its property as an adiabatic condition. So we have the floor selected. You go to construction, and then here there is this tab called adjacency, right? So if you click this drop down menu, the last one is adiabatic condition. Okay. All right, so that's done right there. Then that's it. So now with this definition, everything seems to be the same, but now this ground floor, the floor of this space is not a ground floor anymore. It becomes a floor in a multi-story building with another space below that. So another condition might be that sometimes we like to define one of these walls is an adiabatic condition. For example, we can assume that this is a portion of the building actually continues on. It's very long like that. So this wall becomes adiabatic condition, right? So in that case, probably we don't need these two windows anymore because we're assuming that the space continues on towards the lower left direction. So I'm going to delete these two windows. Again, we're assuming that the model that we did here is a portion of the entire floor. Okay, so this is the entire bar building, but we're only interested in modeling the top part of this building. And without modeling this portion, so this wall becomes adiabatic condition. So you can define that as well in the same manner, right? So you will go to the zone, like this wall. So you select this wall. Instead of that being an exterior wall, you will define it as a adiabatic condition. Okay. Now it just seems like there's nothing has changed much. But this wall essentially has become an adiabatic condition here.